Welcome to Understand the Math. In the video description, you'll find a link to guided notes that can be downloaded and filled in as you follow along with the video. In this video, I'm going to be going over the formula used to calculate the length of a circular arc and complete some example problems. Finding the length of a circular arc is important for analyzing curved paths and is used in the design of various structures, such as bridges, and systems such as those used for navigation. We'll begin with a picture of a circular arc. Theta is the angle that is subtended by the arc. So let's go ahead and write that down. So it's the angle subtended by the arc. And we'll go ahead and add theta to our diagram. And S is the length of the circular arc. And it's also called the arc length. And we will denote that with S in our picture. For completeness, we're also going to label the radius of the circle as R, because we're going to need that later. Let's now suppose that S, our arc, is the entire circumference of a circle. So this gives S is equal to our circumference, which we know to be 2 pi r, and theta, because the arc length is the entire circumference of the circle, theta is equal to 2 pi. Since S and theta are directly proportional to each other, which means as one increases, the other increases, we can write S is to theta as 2 pi r from our formula above over 2 pi is equal to r, because the 2 pi's cancel out. So if we then solve for S, we have S is equal to r times theta, multiplying both sides by theta. So let's go ahead and let's add that. So this is our formula for arc length. So it's S is equal to r times theta. We need to make sure that we note that theta must be in radians. And not degrees. The reason for this is that S and R are both distances. Let's now complete some example problems. In our first problem, we have a circle with a radius of 25 inches, and we're asked to find the length of the arc intercepted by a central angle of pi over 4. We'll begin by drawing our radius and our angle theta. Our radius we'll label as r, and theta is pi over 4. So we'll draw that like this, and we'll label that angle as theta. It's always good when you're completing a problem to write down the information that you're given. So let's write down that r is 25 inches. And you always want to include units with that. And theta is pi over 4. Let's now draw the length of the arc in purple. To find the arc length, we begin by writing down the formula. Our formula is S is equal to r times theta. We can now plug in what r and theta are. R is 25 inches. And theta is pi over 4. So that gives us S is equal to 25 pi over 4 inches. And if we throw that in our calculator, we get a value of 19.63 inches. And let's box that. So this tells us that if our circle has a radius of 25 inches and our angle is pi over 4, our arc length is 19.63 inches. In our second problem, we have a circle with a radius of 9 centimeters, and we're asked to find the length of the arc intercepted by a central angle of 240 degrees. Let's note that in the first problem, our angle was in terms of radians, and in this problem, our angle is in terms of degrees. So for this problem, we're going to have to do an added step of converting our degrees to our radians. We'll begin by writing our radius, r, and then our angle theta, which is 240 degrees. So that angle is less than 270, but greater than 180. So that puts our angle like this. So that's our angle theta. And just like we did for the first problem, let's write our arc in purple. To find the arc length, we'll start with our formula again. S is equal to R times theta. And now we can plug in what R and theta are. Oh, I forgot to write down what our values are. So let's go ahead and let's do that. So our theta is 240 degrees, and our radius is 9 centimeters. So our arc length S is equal to our radius, which is 9 centimeters, times our angle, which is 240 degrees. And now we have that added step that we need to convert from degrees to radians so that all of our units match up. So to convert from degrees to radians, we're going to multiply by pi over 180 degrees. And I have a video explaining why that is if you want to watch that video on converting between degrees and radians. And now let's see what's going to cancel out and combine. So let's see, it looks like we can cancel the 9, goes into 180 20 times. So that leaves us with 240 pi all over 20. Which gives us S is equal to 12 pi centimeters. And we'll go ahead and put centimeters back up on the top one. So S, when we go ahead and throw that into our calculator, we get approximately 37.70 centimeters. And we'll go ahead and box that as well. You should now be able to calculate circular arc length on your own.